Welcome to the final pitches for the Makers for Good make-a-thon at 3D Experience World and for Sustainable Future. It's my pleasure to be here with you all and present you the pitches that we have been working for almost 20 days in this make-a-thon. Okay, so Makers for Good is an open call for makers around the world that will come for designing, prototyping, and launching their products in this program, Hardware Accelerator for makers. So the goals of today, we're going to have a small presentation of the judges. We are going to have a brief message afterwards from Sushit Jain, the VP for SolidWorks at Dassault Systems. And we're going to have the pitches from 9 projects that we actually selected. So I'm really honored to present today the 2 judges that are going to be evaluating today. So Sushit Jain, welcome. He's the Vice President of Strategy and Business Development for the Dassault Systems SolidWorks. Welcome, Sushit. And also, I am presenting to you Armando Laborde. He's the Managing Partner of New Ventures, an accelerator of impact in Mexico City, in Latin America. So I'm really glad to have you here, both helping out with your vision, your experience, and your knowledge to actually evaluate these amazing projects that have been working very hard for the past 20 days. So thank you so much for Dassault Systems SolidWorks for all this support. They actually made it happen for this make-a-thon. They're an amazing platform that is supporting makers around the world. And together with them, we're building this amazing innovation ecosystem, building these strategic alliances with different fab labs, maker spaces, innovation centers, accelerators, factories around the world to make it happen, to make impact happen using digital fabrication and circular economy. Okay, here's a small introduction about the 3D experience. Just for the past 20 days, we received 30 projects, 30 teams, 30 startups from different countries. We actually received 15 different countries. And we have selected for you 8 finalists. They've gone through different masterclasses, 10 masterclasses and 30 mentorships, and a whole methodology from Makers for Good that has been evaluating. Thank you so much for all the mentors that have participated in supporting all these projects. We have more than 20 mentors in this. So we're going to start with the pitches. We're going to start from the pitches. The first project that is going to present to you today is Extreme Mobility Living. Second one, Biomoles, Cycle, Momentum Team, Swapo, Termi, Growy, Team Sudan, and Solar Aqualight. Okay, so I will ask, please, for Serge from Extreme Mobility to please share your presentation and get ready to present. Thank you. Okay, Serge, the microphone is yours. You have 3 minutes to present.
Good morning, guys. I'm Serge, CEO and founder of Extreme. We 3D print sustainable skyscrapers. Did you know 1 billion people are homeless right now? And young families cannot find affordable housing. In Mexico, for example, over 50 million people cannot afford decent housing. And UN projects by 2030, it's going to be 3 billion homeless people. So a business opportunity is to reach out to young families via wedding registries. And eventually, at scale, we're going to reach out to Fortune 500 company employees. Our solution is to 3D print sustainable skyscrapers, which feeds you, provides energy, and housing mobility. So at make-a-thon, today we created energy storage system which extracts 500 liters of water from the top of a skyscraper, generate electricity, and use water in vertical farm. The housing market is very big, and with traditional players like Icon and Mighty Buildings, our patent-granted technology is 5 times faster and 5 times higher versus competition. And by business model, in US, we're gonna sell directly at 250,000 per unit, and at scale, some Fortune 500 companies will sell at 200 per unit for their employees. We project from 10 million to 30 million per building and reaching out 100 million in revenue in 5 years. So we are extreme, building a global network of 3D printed skyscrapers, which are mobile, sustainable, and affordable. And we're led by a great team of hardware engineers, construction, robotics, and mortgage. Thank you very much, and looking forward for your questions.
Oscar, you're muted.
We cannot hear you, Oscar.
Okay, here. Can you hear me now? Judges, do you have some questions? Yes. Any questions for Serge?
Yeah, this is Suchit Jain with SolidWorks. First of all, thank you for the presentation. It was very quick and short. Quick question. So you are talking about 3D printing a whole skyscraper? To tell you frankly, I didn't get that part of it. How do you actually print a skyscraper? Not clear. Maybe can you expand? I mean, how do you print a skyscraper and assemble it?
Yes, that's correct. Our patented technology allows us to print right now up to 15-story high. Traditional 3D printing allows only maybe 1, 2, 3 stories, but our technology allows us to print up to 15 and later eventually even more.
Can you elaborate on that? I've been familiar with 3D printing. Sorry, I'm not sure how you print a skyscraper that high. Do you need a robot that high? Is it a crane? What are you doing to print it, and how feasible it is?
So it's a movable robot. We actually showed in the presentation part of it. We showed a movable robot which allows us to 3D print. Sorry.
All right. Thank you, Serge. Another question, or we move to the next project?
Yes. Can you comment a little bit on what stage are you in? I mean, so you have the technology ready. You mentioned Fortune 500 corporations. Have you engaged with them? Can you tell us a little bit where you are in the project? Is this on the idea stage? Have you begun some conversations already? For us to know exactly where you are standing.
Yeah, thank you for the question. We have a website. 31 people already sign up to buy our properties. We have 4 letters of intent. Past summer, we got US patent granted for our technology, and we have a great team of 18 people ready to execute. We are ready to finance our first construction site, and we want to build our first 3D printed skyscraper in North America. Thank you.
Thank you. Thank you, Serge. Okay, any last question, or we move to the next project? All right, we are going to move to the next project. Thank you so much, Serge. Next project, can you start sharing your screen, please?
Hello, do you see my screen?
Yes, Biomoles. Welcome, Jose. from Biomoles.
Okay, give me a second. There we go. So first of all, hello to everyone. We are Biomold. We build advanced manufacturing process for a circular economy.
Yes.
Give me just 1 second. My computer got stuck. I'm gonna stop sharing the screen. Something happened. Sorry about that.
Question, Oscar, just in the evaluation, we assign coins. So we have to delete the ones okay, just we
Yes,
assign.
yes, thank
Okay.
you. Yeah, in as yeah, exactly. Thank you.
Okay, there we go.
Thank you.
Sorry about that. Okay, so we are Biomold. We build advanced manufacturing process for a circular economy. There's a revolution going within the plastic industry. We're saying goodbye to plastics and saying hello to wood pulp. We've all witnessed this as we shift our plastic bags into cardboard bags. And this process has made the molded fiber industry grow at a rate that wasn't predicted previously. I'm sorry, my computer is not working. Maybe we could make the another group go right now.
Yeah,
I'm
we're
gonna
gonna go
reboot it.
to the next
Yeah.
project.
Yeah.
And then you can maybe fix it, all right?
Yeah, I don't know what's happening. Sorry about that. I'm gonna reboot the
Don't
computer.
worry. Thank you, Jose.
Okay.
Okay, Cycle, can you please share your presentation?
Hello. Yep.
Thank you. Okay, so let me introduce you to Gerardo. He's from the Cycle team.
Hello.
Welcome, Gerardo.
Thank you. Thank you for having me here. Okay. Well, let me share my screen.
Okay, so Gerardo is from Mexico. And welcome, Gerardo Cordero.
Thank you. Well, I'm going to start my presentation. Well, my name is Gerardo Hernández Cordero. I'm from the Cycle team, and well, today I'm going to. I'm having some trouble. Okay. Can you hear me now? Yeah,
Yes.
it's fixed. Well,
Yes.
today I'm going to present you our cycle composting machine. It's a project we've been working on for 3 years. Well, we have a huge problem, and that's the pollution caused by organic waste. It not only pollutes our air, but it not only pollutes our airs, it also pollutes our soils. Because methane, it's a gas that it's 20 times more potent than CO2, and it contributes way more than CO2 in climate change. It causes a rise in climate anxiety. The size of this problem is that it generates 8 million metric tons of organic waste and generates a rise in climate anxiety in a 47% in 2019 and a 68% in 2020. Our solution to this problem is creating it's a way to recycle materials, organic waste, into useful materials like compost. That's where Cycle comes in. In 2020, the searches for the word compost were a total of 5,200,000. So it validates our theory that people is interested in reducing their waste to reduce their organic waste. So this is Cycle. It has many advantages. First of all, it's easy to operate. Making compost has always been a lengthy process that requires specialized tools and specialized knowledge. But with this machine, the average person can produce their own compost and recycle organic waste. It has a faster process for normal consumers. It has a high capacity for continuous use and reduced to nil smell emissions. It doesn't consume a lot of energy, and by the tests we have been doing, there's a user satisfaction. by reducing their carbon footprint and greenhouse effect gas. This is how the mechanism operates. We have 7 chambers. In those chambers, the organic waste gets filtered, loses water, and passes through the next filter. That way, when it comes to the composting chamber, it's ready to compost and make a useful material. This is practically how it operates. It consumes only 750 watts of energy and has a volume of 21 liters. The production cost is $228 US. And well, this is our schematic of how it works. This is the 7 levels of filtering, and these parts here are just some shovels, mechanical shovels, who move around the waste in order for it to don't get stuck in a level, so it can continuously have more and more organic waste getting composed. This is a comparison of our the competence. Most of the equipment you see here is professional equipment, things that professional people who dedicate to make compost have, and yeah, they're good, but they are for professionals and they're hard to use. They're not for the average consumer. This is where Cycle comes in. It makes this lengthy and tedious process into something as easy as throwing your trash into a trash bin. Well, this is our business model. We plan to sell not only the machines, but we also plan to sell some optional microtransactions, like microorganisms who speed up the process, enzymes who speed up the process, dry material to make a better quality compost, and some smell filters because they're eventually going to wear out. We also plan to sell different attachments and colors, for example, different cosmetic pieces and different color bundles and everything like that. And we plan something to launch our product that's a responsible consumption proposal. You have to buy one, and we donate the price, well, half of the price, to some non-profit organization. We plan to sell, well, there are more than 34 million homes in Mexico, and 90% of them are in a socioeconomic status ABC+. The potential market, at least in Mexico, is 11,628 potential consumers, which, even if a tiny part of that potential market buys one of these machines, that will leave us with a $7 million revenue for 2022. And this number can be more than double on developed countries. In conclusion, we have a competitive price, an accessible machine in an emerging market. Well, this is the founding team: Jan Hernandez, the captain of the team; Emilio Hernandez, he is our consultant in everything related to botany; and me, Gerardo Hernandez Cordero, designer of the machine.
Thank you so much, Gerardo. Okay, please, Sushi and Armando, do you have some questions?
Sure. Thank you. Good presentation, guys. This is Suchit Jain. Quick question, maybe the question, Armando, you asked for the last team. What stage you guys are in? You're talking about, you showed some nice picture of your design, by the way, very attractive design. I think it also is a good purpose. But what stage are you at? Is it just that you have some designs? And by the way, what CAD software they are done it? So that's one question. And what stage you are really at? You are, design, prototype, market?
We are currently on the prototype stage.
Okay. What does that mean? That you have actually created a prototype, or is just a design right now on computer?
We have tested the principle and how this works. We have tested the filters, and now we are adding the mechanical parts to it, the automatization. But the filtering process has been tested, and we're currently building the automatization part.
I have a quick question, Gerardo. So this is for family use. I mean, how many kilos of waste can I dispose in the machine? And it wasn't clear to me if you can comment. I mean, it says that when the compost dehydrates, it goes to a lower chamber and lower chamber. That does that happen automatically, or it has to be like shaken or compressed, or just how it goes down? I mean, and I just would love to know the capacity and how that goes down.
Well, good question. Yeah, it's measured in liters because the volume constantly evolves. It can weigh, for example, trash, organic waste isn't something that has a constant volume. So we cannot measure it in kilograms. We measure it in volume. So yeah, it holds up to 21 liters at a time, but it constantly shrinks. Well, it constantly changes because the organic waste shrinks when it loses water. And we have here in this part a fluid chamber where those fluids, when they are released from the organic waste, go, and the user can simply just pull them out of there, and they're constantly leaking. Leaking down. They're constantly well, there are no fluids in the machine when it's operating, and yeah, it's a process that happens automatically. The trash loses fluids automatically.
So it goes by gravity, just goes down with
By gravity. By natural processes.
How long does it take? I mean, if I put something at the top today, I mean, by how many days does it require to go through the whole process of decomposing and having the compost ready?
Well, it starts to lose fluids since the first day, but it completely loses water up to the week 2. But by the time it loses all its water, it has already passed up to this point and into the composting chamber. So it's always a free space for new organic waste.
Perfect.
Well, but just a quick question, maybe a follow-up on there. Where is the solid part of it going? So I understand that the liquid goes down in the drain at the bottom tank. But what happens to the solid waste? I'm assuming it reduces in volume, but what happens to that?
Solids don't go into the fluid chamber because we have some design pieces to avoid precisely that.
But where does it go?
The fluids go here into the fluid chamber, and it stays here. In the solid parts stay here in this part in the composting chambers, and they're completely separate from the fluid chamber. Yeah, it has some filtering, but only fluids can pass through that filter.
Okay, and maybe a quick question: is this CAD? What you're showing, is this a drawing or is it a CAD model?
It's a CAD model.
And is you use 3D Experience software, SolidWorks software to do that?
Yep.
Okay, thank you.
Thank you so much, Gerardo. Thank you, Armando. We go to the next project, please. Momentum project. Abdullah, please get ready. Share your screen.
Quick question for you, Oscar. I mean,
Yes.
for the evaluation, do you change the slide, or we can find the
Actually, you see it there. Let me just, if you follow me, that's Gerardo. He is going to be, he's here.
Maybe Oscar, I'll give Armando advice because I did it. Armando, you can zoom out, zoom in.
Oh,
and,
perfect.
You know, the whole thing is on a piece of paper, so you have to slide it in.
Perfect. Thank you.
Yes, thank you so much.
Thank you, Sushit.
Thank you. Okay, so as the judges, they start evaluating. Abdullah, please get ready. Are you here?
Yeah, I'm ready. Yeah.
Nice.
Let's go.
Okay, so please, I'd like to present to you Momentum team. Abdullah from Egypt, welcome.
Welcome all. Welcome all. We are Momentum from Egypt. We'll first start with the problem. In 2050, the percentage of plastic will be greater than the percentage of fish in oceans. And because of that, some of sea creatures are on the average of extinction. 1 out of 3 code for human consumption contains plastic. By numbers, at Egypt only we have 4.5 million tons of plastic waste at our River Nile, and by the world, 8.3 billion tons of plastic waste each year. That's the total number, and each year it's increasing exponentially, the plastic waste in the water. If we have a market size based on the way plastic waste management market is going to be 38 billion by 2040. This problem touches the Sustainable Development Goals in 3 of them: clean water, climate change, and life below water. So we have this robot for water cleaning robot to clean the water from the waste. That's the first version. We already made it, the prototype. That's working for. That's a video for it. It's working to collect from 5 to 10 kilos plastic waste. We tested it in Egypt already and do a great well in that. But we face the problem that we say that 5 to 10 kilos. We need to increase the consumptions for 200 kilograms per time. So that we develop a new prototype for that. That's using new technology, artificial intelligence, to detect the plastic waste using 2 cameras, as mentioned, and the motors to move the robot. We go to detect the plastic waste. After that, we go to collect it. Our business model is B2B and B2G, business to business, for the beaches and the hotels and restaurants, resorts based on water. Also, we have contract with recycling companies. After we collect the waste from the water, we give it to the recycling company with money. Also, we have a contract with the Ministry of Environment at Egypt here, business to government, and we working with a contract with Ministry of Tourism here in Egypt. If we want to see it by numbers, if we manufacture 1 robot, it costs about $6,000. The sales forecast for 1 year working with 1 robot is about $100,000, and net profit about $85,000. That's about 1 robot. We can multiply this number by the number of robots. Also, we design the integrated system so that we can clean fastly with more than robot in the same time. Our competitive advantage: we are the first surface to clean the beaches by order. Capacity 200 kilograms per time. Are the fastest way to collect the plastic from the water. Let's conclude. Let's clean the water and save our wallet. That's a render video using SolidWorks and 3D experience tools for the new prototype. That's our team with a diverse background: business development, mechatronics engineering. Thanks a lot for your time. Thanks. I'm here if there are any questions.
Well, this is Suchit again. I think very well done presentation. I like the concepts, very good animations and illustrations of what you're doing. I am familiar with the, similar kinds of machines which have been made to collect and clean. I'm not clear on your differentiation again compared to what's happening in other parts of the world. Is it just a more cost-effective way of doing it, which is unique to your local region where you are? Maybe if you can comment on that a little bit, because I know. So if you can just point out the uniqueness again for me compared to other machines out there which are doing very same thing.
Yeah, we are the first one by order. Other machines, as first of all, the initial cost by millions to make machines to clean the water, as we can see in New Zealand and USA, machines used to collect the water. That's the first. Second thing, we use AI to detect the waste before collecting it, as we targeting in the next version to sort the waste, not only collect. So that we're using cameras and have algorithm of artificial intelligence to detect the waste and sort it to recycle it well without any time waste. I want to confirm also that we are the first by order. You can order us tomorrow and they will come with the robot and we work to clean all the beach or the water. you can order us. We are the low initial cost, and you can order us. That's it. I hope it direct.
Thank you, Abdullah. Another question from
just quick question. Congratulations on your prototype. You says the machine detects the plastic, and I'm just kind of curious what kind of plastic. I mean, how that works. I mean, it's just you just mentioned cameras, and I'm just want to know what kind of plastic you can withdraw from the water. It's more like bottles and small bags, or what happens if you find a fishing net or something like that? Just if you can describe a little bit what kind of products you can this machine can retrieve from the water.
Yeah, the first version is working only for the bottles. Bottle plastic, we collect it. But in the next version, as we mentioned, we will collect all the types of plastics, PTE. Also, we have developed a system for after detecting the plastic, searching for the best recycling tool for that. And we have a contract with the recycling company. After we collect the plastic based on its type, we'll give it the company.
But it's for floating plastic, correct? Or
Yeah.
Okay.
A quick question here, which I'm not clear. So I know you're talking about floating plastics. Maybe you can comment on how far into the ocean you're going, because you mentioned about beach cleanup. Beach cleanup, I don't know how many plastic bottles are surfacing and coming closer to the beaches, and how many are close to a beach per se. So I'm just wondering the viability of this, because I've seen these things which go deep inside the ocean and try to clean the bottles. So I'm just trying to understand. You talk about plastic bottles, but how far you're going.
Yeah. For the financial model, we made that for the restaurants here in Egypt. We have a tourism hotels based on the water, and it has a waste around this restaurant or hotels or resorts. So
not just the beach. In this case, it will be a restaurant which is around a beach or a river or anything. Is that what you're saying?
Anything, yeah.
Okay.
Thank you. Okay. So yeah, we're gonna go to the SOAPO team now. Please, and I'd like to present to you Andre from the SOAPO team. Welcome, Andre.
Hi, thank you.
I'm gonna give some minutes for the judges to evaluate, and just a few seconds. Please just get your presentation ready. Okay. Thank you. Welcome, Andre from SOAPO. He comes from Mexico. Welcome.
Thank you. Hi. Did you know that from year 2021, from today, the soap consumption in Mexico increased 43%? However, this increase in cleaning products has also brought an increase in plastic waste. Just all around the world, we generate 8 billion tons per year. A recent research made by Semarnat estimates that one person generates 1 kilo or 2 pounds of waste every day. Just talking about soap industry, it's valued in $18.2 billion globally, and this industry represents $200 million in Mexico, and it's growing. At this situation, we decided to create SOAPO, your smart refilling machine that offers 4 cleaning products that every home needs, like soap and sanitizer. How does it work? It's very easy. You only need to choose your product and the quantity that you would like to buy. After that, you need to put your empty bottle in the machine, make the payment, and take it and go. As simple as this. Our competitors are 2, the wholesalers and the retail stores. But you need to take transportation to get the store. Our target is focused to put our machine into the households or into the apartment units or residential areas to take advantage of the population flow. Our machine, of course, is allocated in strategic areas to preserve its own integrity. Our competitive advantage. We support green economy with less waste and bring convenience. Our business model is B2C. We operate under vending machine scheme, and we obtain 30% of profit per liter of product sold. We offer a sustainable and profitable model, and we innovate in the way to deliver cleaning products. The team is working with 2 key members that are members of the unit belongs as a neighborhood committee, who are very interested to release a pilot that they are located in the south of Mexico City. With your support, we can build a functional prototype. We care the present to preserve the future. Thank you.
Thank you, Andre. Judges, do you have some questions?
Suchit, again, I missed the presentation was very short and it went very fast. I'm not clear. Maybe if you can just quickly go back to the first slide. Can you just tell me again what exactly you're doing, the purpose?
Yeah. Okay. We are elaborating a soap refilling machine. There is our model. We create
could you repeat that, please?
Yeah. We create a refilling machine that brings the people the convenience to reuse their empty soap bottles.
Okay, I understand. So maybe explain to me, how is this a real need? I mean, I understand that you can recycle, but soap bottles, is there people will go out somewhere to refill their soap bottles? What is the customer research you have done? Is this a little bit of a need, or I'm not clear on, at least I'm not seeing a real need for this and people will do it, but maybe I'm missing something.
Okay, we have two situations. The first is that here in Mexico City, the increase of waste generation just rocketed to the sky. And in another part, the people start getting to consume more soap and cleaning products. Here in Mexico, we have a lot of apartment units or residential areas. And in some areas, they need to pay for collectors to get their trash out. We find an opportunity to bring this kind of products that are a first necessity product, to bring a different way to deliver this kind of products. Like, so this generates convenience. And we also make several surveys to know if we are reaching our target, and we got a very good support. Actually, we already are in talks with 2 members of a committee that are in a very big residential area that have a lot of apartment units, and they see this like a big opportunity to reduce their waste and bring a service, making the people to get the product without leaving their homes.
Okay, I understand. So this would be a soap like bath soap and liquid soap which people use, and you want to refill it. So rather than buying a new bottle and then throwing that away, you are saying that you can essentially reuse those bottles and go to a station if in a big apartment complex, refill it there, and then bring it back. Okay, understood.
Yeah, Gerardo, I do like the idea. I mean, we have seen some entrepreneurs going more into the wholesale kind of thing, more for products, I mean, for food products and things like that. So I think it's an interesting approach, and the fact I'm trying to set it up at the apartments. Just quick questions. I mean, can you tell us a little bit what stage are you in? I mean, you mentioned that just getting into the prototype. So if I understand correctly, this is just an idea at the moment. And if you can get into more detail, what kind of products are you thinking of? I mean, you mentioned before, what would that be?
Okay. First, we already have the plans, and until we close the deal with this apartment unit, we are going to create our MVP. We are going to use a cartoon board to prove the concept. And the main objective here is to reduce the plastic waste, bringing a new way to reuse their empty bottles.
And what products are you thinking of? I mean, it's
yeah, we're offering 4 products. The first is hand soap. The second is dishwasher, of course, sanitizer, and cleaning floor are the most common products that in Mexico that people use.
Sorry.
No, go ahead, Sushi, go ahead.
No, I agree with you, Armando. I find it, once I understand it, it seems interesting idea. It's like a vending machine for your household stuff. So, but so the filling of it, so you guys will service it, you will buy these different products, put it in the vending machine in the back, and then the user will select whatever they want, and then they put the bottle in there. Somehow, I'm assuming, just like filling water or something else, which people do in vending machine, you will do it for the liquid soaps in there. Have you worked out the engineering of dispensing all of the different viscosities of these, these machine bend? So how much of engineering, so concept-wise, I like it, but how much of engineering have you done to resolve all the issues which will come over usage of these vending machines over time, right?
It was challenging. We also in this release, we defined to put the containers in the outside to use the gravity, and we put 4 pumps to start the extraction in the case that the viscosity start to slow down or just maybe avoid to get the flow. And we already have the engineering to make this work in the best way, and we actually have all the electronics done.
So you are saying you have engineering done, and again, not as a concept, but you have.
We perform a small test using sanitizer to verify that this works in a good way. And yeah, we find some issues and we fix it because the viscosity in some times make that the pump start to heating, and this can damage the pipes. And until this situation happen, we re-engineer to make this. We have a part of functional things, but we don't ensemble all of this. We only make a part to verify that this works.
All right, thank you, Andre.
Thank you.
All right, thank you. So any more questions from the judges, Armando or Sushi?
No.
No,
thank you. Okay, thank you so much, Armando. And
thank you, Oscar, for the invitation. As we talk, I'm gonna have to.
Yeah, no worries. We're gonna switch the judge. Lily is coming now.
Okay, perfect. So
thank you.
Thank you so much. Nice.
Thank you, Armando.
Congratulations to all entrepreneurs.
Thank you, Armando.
Thank you, Armando. Okay, now Lily's here. Thank you. Okay, so it's my pleasure as well to present Termi, Andrea Merino from Mexico. It's a health startup. Welcome, Andre. Are you ready to present?
Hello. Yes, I'm ready.
Thank you so much. Welcome. Just give me a few minutes for the judges to,
of course,
to give the evaluation, and we're gonna start. Thank you so much. Okay. There you go. Thank you. Okay, you might start now, Andre.
Okay. Hello, I am Andre Merino. I'm co-founder of Termi, a Mexican health tech company with a mission of save lives through early breast cancer detection. According to the World Health Organization, breast cancer is the deadliest for women. There are more than 2 million new cases every year, which means that every 15 seconds, a woman in the world is diagnosed. And statistically, 1 in 7 women we know will have it at some stage of their life. But the worst part is that up to 75% of the total cases will be diagnosed at a late stage of the disease. There is a huge problem, but also a huge opportunity. There are over 2.2 billion women that need a breast cancer screening every year. Our market in Mexico and Latam is the 200 million women. And our goal is to turn by 2026 our first million women and sell 3,500 thermi units. We're talking about a market of $5.4 billion only for breast cancer, and that will even grow 8% by 2028. We know the only solution for this growing problem is the early detection. Therefore, we have created and patented an accessible medical device using thermal images powered by artificial intelligence software in order to change this reality. But how does it work? We take thermal image of the body's patient, we apply the AI analysis, and we get a fast result. The whole study is done in less than 15 minutes. Of course, Thermi offers great advantages for women, for physicians, and for the institutions. But the most important, Thermi allows the early detections, which equals more life saving. There are other companies with innovative proposals. However, we really use artificial intelligence and we validate our algorithms to reach the highest sensitivity and efficiency with a lower technology adoption cost. Besides, we have clinical trials done, our machine learning database, the PCT pattern, a strong team, and the unique business model, which has two revenue sources. The first one is the breast cancer screening campaigns through service contracts. And the second one is through direct sales of the Thermi device, plus a monthly software license. With the revenue from both models, we expect incomes of $20 million, which also means to help more than 1 million women only the next 5 years. Behind Thermi, there is a complete team formed by 5 founders specialized in finances, software development, research, sales, and marketing, and more than 15 collaborators fully committed and passionate about this cause. Finally, let me remind you, today more than ever, your health is the most important thing. So let's make prevention a habit. Let's save lives. Let's just start it. Thank you very much.
Thank you so much, Andre. Judges, Sushi, do you have some questions?
Sure. First of all, Andre, thanks a lot. Very clear presentation. Of course, it seems like you're far ahead in compared to some of the other teams. You've been working on this project for a while. Seems like you have a very good team, and you're further ahead in it. My question is, of course, this is high cost project implementation, medical FDA approvals in US, especially all of those kinds of things. So could you tell us a little bit more about, you did mention competition here, and some of them probably are big players. So how do you, where you are and what kind of, from a business perspective, where you are, and then also maybe you can comment on you mentioned the thermal imaging and decision, so I understand that. However, what is your differentiation compared to some other companies who are doing the same thing?
Sure, thank you for your question. Well, we are done our clinical validation trials, so we just start to sell. Actually, this year start in the next week with our first pay client. So we have some differentiations for the other companies. We have one important in India, but here in Mexico and Latam, we have the market clear for speak. And yeah, we know our technology has the COFEPRIS approval, like the FDA in USA. That's permission, costs almost 3 years to the applied studies. So we sure that we are ready to start the scale up, this expansion with this project, and start to save thousands of lives.
Okay.
Thank you.
Thank you.
Another question from judges, Lily?
Hi, Andre. Yes, I have 3 questions. What is the stage of the prototype? And how many patients have you tested so far? And if you can, please repeat the value proposition because it wasn't so clear for me, please.
Sure. We are done more than 4,000 studies free of charge, and we find more than 150 positive cases. These cases are confirmed by mammography and biopsy. So we have an excellent database. For the differentiations, we already have the product, the MVP ready to start commercialization, to operate in Mexico and some countries of the time. So our costs, our business model only costs $10 per study. And our device, the whole Thermi device, costs only a sixth part of the mammography machine. So we have a really competitive advantages of our device. And we have these 2 models, two kinds of services. So a little clinic or lab can ally with us, and we start to help a local woman in whatever place. So also we have to help a young woman start of 20 years old instead of 40 or 50 years old on a mammography machine are the biggest differentiation.
Thank you.
I have further question, Andre. I know that, I just want to make sure, because I'm comparing against some of the other teams and some of them are very early in this stage. Of course, it seems like, you had the slide up in terms of all the places and the startup accelerators, et cetera, you've been. So it seems like you've been at it for some time and you're bringing this machine to the market, which is all great. And it looks pretty awesome in terms of where you are. Still, I have a question, what is your technologically, you talked about thermal imaging, and then of course you talked about AI of detecting. Is that, what is your secret sauce in all of this? Is it just about bringing all of that to the market at a cheaper cost? Or is it that you truly have something unique in terms of AI, which can take this thermal imaging and then other people can't detect breast cancer, but you can? Or, what is it? What is your innovation?
Okay, interesting question. Well, actually, we are bionic engineers. This was my project to the career. So, yes, there are a lot of investigation before about the thermography, about the cancer screening, but they didn't apply AI, artificial intelligence, and we collect these 2 areas of opportunity, the thermographic technology and the artificial intelligence, and we also do the investigation, the clinic validation that neither other companies done before. So we offer to the public, to the commercial public market, this opportunity to use both technologies in one proposal. So in this way, we want to offer a pregnancy test, but for breast cancer. So is the novel way into the process of mammography test. And so, well, we sure that this option can make a difference in the world.
So you are saying that the mammography you want to apply it at the consumer level. So rather than going to a doctor who's prescribing, going to the hospital as a consumer, you can start to do more of these tests, right? That's what you're saying?
Yes, because one of the biggest problems is the woman don't approach these methods like mammography, ultrasound, the resonance, magnetic resonance, but because for the fear, for the pain of these options, for the cost even. So with Thermi, they can go to the a clinic near of them and do this study non-invasive, painless, radiation-free, and well, we know we think that it will be better. This.
No, I think it's a good idea. I think and you probably have done your thing, but of course, you have to have very high level of confidence because you can't get into false positives and so on and so forth. So I'm assuming you're doing a lot of work around those kinds of things. Okay, thank you.
Well, thank you.
Thank you so much, Greg. Thank you so much, Sujit and Lily. Okay, it's my pleasure to present to you now Mario Andres from Groy. It's a Mexican team as well. Mario, Andres, are you ready? Mario?
Hi, everyone. Yeah, of course.
Thank you.
Please.
Okay, Mario right now is in Acapulco. He's from Acapulco, right?
Yeah, right now I'm here right now.
Thank you. All right.
Okay, well, I'm Mario de los Santos. Our project is growing, and let's start. The footprint generated for the logistics and transport that is working right now around the world, moving the vegetables and fruits and all these parts, generates around the 30% of the environmental impact around the world. So adding to this, the pesticides and fertilizers used to cultivate this food and the logistic prices and costs to transport these vegetables around the world are some of the problems that we are taking care about with our project. I'm just making a little example and context. Produce one lettuce consumes around 30 liters of water per lettuce. Just in Mexico in 2019, 500 tons of these vegetables are consumed. So almost double in the United States. Making the counts, we can get some crazy numbers around the consume that we are getting in that part. And also, we need to take care about the vegetable waste. We lost around the 40% of the vegetable producer in the chain from the production to the consumption. So that's another point that we want to take care using this project in local services. We want to change the status of the massive systems of the cultivation consumption. So creating some farms inside the cities, creating these vertical farms that for now, we are going to innovate as part with our products. How? Well, the growing system will be able to generate more healthy and organic products. So the consumer will be more confident with what he's eating and what he's getting. What is the idea that we got? What is the project that we got? We have two parts of this project. We're going to divide it in the growing autonomy system that is including the hardware. The system that you can see here, this tower, is basically a modular system that will cultivate the vegetable that you are going to be adding to the modules. And the marketplace. The marketplace is very important for us because the marketplace will be the window between the customers and the businesses to more organic and healthy food. So you as customer will be able to have your own vegetables on house, and you can, with the marketplace, you will be able to commerce with these parts. And well, the value proposition, we're going to generate more income for the people that will be able to invest in our farms, will be able to produce more income in their houses through the marketplace that we're going to give it to them too. The local consumption, all the vertical farm will be in the same location. So we'll be able to get more healthy and fresh vegetables in your city for your consumption and generate transparency. So the users will be able to sell the vegetable directly to other consumers. So that's very important too. The first part, the marketplace, we need to identify the location of the growing, the vertical farm. So the people will register what they have, and through the app, through the marketplace, other customers and restaurants will be able to get those vegetables and fruit. This is just a little render of app. And about the hardware, well, we are thinking to create a modular system. So we are going to have the distribution part of the pods that will be the vegetables to including the cassettes. And the brain, basically, this part will be the control of the system. Each cassette will have a modular system, an independent system that will monitor the condition of the vegetables, and we ask what the needs to the brain. So the brain will be able to add more cassettes. So just using one brain, we'll be able to extend the cassette consumption and the cassette control. And where we are with the competition, where? Well, comparing with the prices and the things that are similar in the market for vertical farms, no considering the marketplace that we are adding to our product model. So we are around the 700 euros. So we are in the middle of the competition. So we have a good window to work with. Well, our competitive advantages directly with those other companies around is the premium live vegetables. We're going to distribute the vegetables, so the cassette will be more confident in our organic line that we are going to be providing. 0% MER, 80% of water safe, more plants per square meter, 50% less electricity use, and the model that we talked about before, the C2C model, the customer to customer sale. And also we are adding the B2B model that will be a restaurant having growers vending to other restaurants that needs the vegetables. So we're going to have those models, the C2C and the B2B. And the next steps, well, we want to start with 50 restaurants pilots. So we're going to have 50 rows in 50 restaurants, and the restaurants will be able to get those vegetables and models from another restaurants, creating a little network behind them. Well, that's all. I'm Mario de los Santos, a hardware engineer, and this team we also include Joshua Gomez and Karen Zamora, who are the industrial designers. And thank you for joining us.
Thank you, Mario. Any questions from the judges?
Yeah, I have a comment and a question. So Mario, first of all, great presentation. You know, at SolidWorks, we used to have a customer right here in Boston, where I am, a customer called Freight Farms, and they were doing vertical farming. You probably are familiar with them. They used to do the same thing, but in a freight, large size. What I like about what and probably I don't understand it that well, and probably I like to understand it later at some point. We don't have enough time. I like this idea of modularity which you bring to the table, because that was one of the constraints in the freight farm. And what I'm not very clear on is the brain part of it, which again I like the concept, the storage, and what the business models around that is, because I think you're trying to do something pretty unique in there. So I'm very interested in it, but I do not understand very clearly that part of it. If you want to comment on it, you can, but let me just put the other question I have is this, of course, you are an industrial designer, so you have some very beautiful pictures and concepts. Where are you in terms of the stage of this?
Okay, we have already to just start manufacturing the cases, and we are working to develop the hardware part. So for the modularity, we are going to be working around the concept created 2 years ago for the Fab Lab, and this researcher Navia that was working directly within the Arsenal field in the Fab Lab, and that they call the object-oriented hardware. So we're going to be working creating the brain of the system with the capability to be joined to more nodes or slaves in this cassette. So we are going to work with that part to create the modularity in the system. And yeah, you are already working hard in the hardware part, and we are ready to produce the physical design, the industrial design.
Okay, thank you.
Yeah, of course.
Any more questions, Lily?
Yes. Hi, Mario.
Hi.
Where are the vegetables grow? Inside this machine or in another place?
Okay, we are going to distribute the pots. There are these parts, and the people just have to add them to the cassettes, and the cassette will be, and the system, the complete system will be the interaction that was going to grow the vegetables. So basically, you are going to cultivate the vegetables and the fruits in your house.
But I don't get the idea of the cassette. Can you explain it better, please?
Okay, yeah, of course. Each part of the model, for you can see here, for example, this part that had some lettuce are some cassettes that are going to be removed and put it on as you will changing the fruit. So, for example, if the rapid comes to house to get some lettuces, you're going to get out the cassette, give it to the reparted, and you're going to have a new cassette just mounted all in the system. So that's the modular part. So those parts that have the vegetables are removed, and you can change it for a new cultivar.
Thank you.
Yeah, of course.
Thank you. Another question, Sushit? More questions, or?
Let's move on. Maybe Oscar, just a question for you. I want to do the time check as well. I know there's other teams.
Yeah, we have three more teams.
3 more teams. So what is your yeah, so how long more? Just because I know maybe there's some audience and everybody else, but just can you give a time check?
Yeah, I think we're gonna have like 15 more minutes.
Okay.
Maximum. Is that okay?
I will stop sharing now.
Yes.
Thank you.
Thank you for your time. Yeah.
Okay, so please, I'm asking Mohammed from the Sudan team. It's actually a team from Sudan that is going to present now. Mohammed, are you ready?
Yeah, I am ready.
Thank you, Mohammed.
Thank
Go
you.
for it.
Okay.
Okay, so we'll give some minutes as well for the judges also, if you want to give some evaluation for the last project. And as Mohammed gets ready.
Okay. Are you seeing my screen?
Yes, we can see it.
Yeah, hello everyone. My name is Mohammed Miktaba. I am representing FGC Team Sudan. Our product is a smart stick for blind mobility. There is a blind people in Sudan, and we want to solve this problem. So the main problem is to help them. The size of the problem, we have more than 200 blind people in Sudan and 43 million blind people in the world. The business opportunity, the total revenue, if we goes in Sudan, $5 million, and if you check the around the world, it will take $1 billion. Our solution is a smart stick designed initially in SolidWorks and complete the design in 3D experience. Mainly it's helping blind people notifying obstacles by sensors, water sensors, vibration sensors, and all this stuff. So this is our solution. Actually, the main feature is chargeable. You can charge your stick. You can use water sensors. If you have a water in the ground, basically we have a lot of water in Sudan. There is a bad infrastructure here, so that's a water sensor, and high obstacle sensors for the upper part of the body. We are the first company here in Sudan. All the companies or all this the project in this field is just a prototype, not a company. It's a suitable price. The competitive, actually, the competitive advantage, the competitive analysis is we are the only company here in Sudan. So basically, in Sudan is a good opportunity to start. And globally, we have WeWork company. The price of the can is $9,900, and Bawa is also another can. The business model starts with manufacturing and sales and blind people. The financial projection, the manufacturing cost is $80. The revenue is $20. The total forecast for if we sell 10,000 to 10,000 people, it take $1 billion, and the total revenue $200,000. The summary is we have first smart tech in Sudan, effective solution, especially here, new durable design. Thank you all of us. I am Mohammed Muktaba, and this is all of my team. Thank you for your time.
Thank you, Mohammed. Any questions from the judges?
Sure, Mohammed. First of all, thank you, and presenting from all the way from Sudan. That's interesting to see all the different parts of the world in the presentation. Very clear and good presentation from you. The only question, and I'm familiar with these kinds of sticks for the blind people. I think it's good concept. My question is the cost and affordability. Still, I mean, you're talking about $100 stick. Is that in Sudan? Is it affordable? I mean, you're talking about a certain market size and all of those kinds of things. So I'm just worried your business model and the viability and the cost and all of that.
The cost is basically for manufacturing 3D printing out of Sudan, but the main infrastructure here in Sudan, the cost may be more than $80, but the manufacturing cost in the US 3D printing standard cost, and the others electronic from Amazon and all the electronics, so it takes $800. In Sudan, you can estimate the cost, but that's the initial cost.
Okay, and what stage are you at? Because of course, it's something like this, which is on a daily use, has to be very rugged and everything. So, because it has to weather. You are in heat, you are in sun, you are in maybe even water, all of those kinds of things. So this is kind of outside the home use a lot of times. I mean, is this just in a concept phase, or have you done anything to really make sure you address all those things? Because 3D printing thing is good for certain things, but if you put in water, maybe there's, so you need the right quality of products for it.
Yeah, we make a prototype from small sheet metals and all of this stuff, but we never made the 3D printing. We are in the concept design. The sensors and all electronic stuff was tested in the first prototype. It was not 3D printing, but it was tested. So it worked good.
Thank you. Thank you. Any questions so far, Lily? You have another question?
No, I have one question. Sushit already asked about it. So thank you, Mohammed.
Thank you.
Okay, so we are going to go to the next scene. And please, can you get ready? So I like to present Edgar from Solar and Aqua. This is another project from Mexico. Thank you, Edgar. Are you ready?
Yes.
Thank you. Okay, welcome, Edgar. The microphone is yours.
Thank you. In 1 year, almost 100,000 children die here in Mexico because of potable water, and 1 million dies around the world. And even some people are killing some drivers to get these water trucks to get water to their homes. Around 50% of the water here in Mexico, it's contaminated, and 20 million don't have access to potable water. That means that there is a market of $5 billion to take solutions to these people. A solution that we can take is a rainwater collector. The water flows from the roof of the house, and it fills a first water container. This first water container eliminates the 75% of the contaminants, and after it is full, it is deviated to another water tank, and when it's full, we can make a purification process to have potable water. There are some solutions in the market, not too many, but the storage and the transportation, it's not, they don't have a solution for this. And it's expensive, and also transport a lot of air, produces a lot of CO2 emissions. For that reason, we are making this design that it's a stack solution, and with this we can solve the transportation and also the storage problem. We already have two rainwater collectors that we installed 4 years ago, and they are working in a house, and in one day we can collect around 40,000 liters of water. And with nanotechnology, we can purify the water, and with this, it is safe to drink it. Our competitors are around $50 to $100 above our price, and they don't have a stack solution. And our solution also have the possibility to use it after the rain season, which means we can open it, we can clean it, and we can use it, for example, in rainwater collection. Every year, the government in Mexico are investing around $20 million in these technologies to bring potable water to Mexican communities. And how do we make money? By selling the kits. Also, if the client requires, we can make the installation. We can charge for transportation. After every year, it's needed to change the filters, and it can be used as franchise, selling the rainwaters and the water for the people that need it. Our goal is to sell 1,000 systems in the first year, and grow in 3,000 or 5,000 systems every year. And you are not only investing in this system, but also in other ideas that we are working at, and there are many others that are going to come. In summary, what you are doing is save many children's lives, reduce the CO2 emissions with these stacked solutions, and also that we can use it after the rain season. This is our team. I am a mechanical engineer with 7 years of experience doing research and development, and Lina, she has 16 years of digital marketing experience. And there are others that are involved in the project. And now I'm open to answer your questions. Thank you very much.
Thank you.
Thanks, Ed. Yeah, thanks, Edgar. This is Suchit. Thanks for the presentation. I have a couple of questions here, which I'm not clear. So you talked about this stacked solution. Is this just the stack solution for collecting and then transporting, and all the cleaning happens in the schematic diagrams you were showing? there is that big tank, and then you take the water from that tank and then distribute it through your stack thing. Is that what it is?
Yes,
Right.
this system, what makes it collects the first part of the rain, which is polluted, and it eliminates the 75% of the contaminants. And after that, there is another process to eliminate the other 25% inside the big water tank. And we use nanotechnology to eliminate the rest of the pollutants in the water.
No, let me repeat my question. I understand that you're cleaning it, but I'm trying to understand if the cleaning is happening inside one of these blue. Can you go back to those blue boxes? You have the stacked ones. Yeah. Is the cleaning happening inside this box, or this is just for transportation?
It can be both, but it's only for transportation now. But the purification process can be taken also inside the boxes.
Yeah. Okay. So if this is for transportation now, here's what I don't understand. The question, first of all, if it's just for transportation, why not just buy any existing? There's hundreds of different kinds of stacked boxes in which you can put there. So why do we need that? And secondly, it's good to have a stacked solution for getting the box to the water, but once it's with the water, you can't stack it anymore, right? In fact, it's one of the worst way to transport now filled things. In fact, the picture you were showing earlier for some of your competitor, they actually have better solutions now for when you are transporting something which is already filled, because you can actually stack them and fit them together when they are filled. So I'm not understanding the benefit of the stacked solution the way you described.
These containers are empty now. They don't have water inside, and they put it in these trucks to transport them and then install them in the houses.
No, I get it, but I think they are designed that if they are filled and then you need to transport that filled water somewhere else, that they can fit together in a nice grid. That's what I'm seeing from the picture, so that even if they are filled,
no,
they can be transported.
They are never filled inside the trucks, and also yes, the problem is that there is a huge pressure that comes from the rain from the pipe. It's around 300 to 500 kilograms of pressure, and it is necessary to build a special box for rain collection. And also the amount of water required, it's around 200 liters, and it is also necessary to create a special mold for rainwater collection. It is not possible to use a regular box in that case.
Yeah, no, maybe Edgar, I'm sorry, I probably didn't understand it, because I thought you said this is not for collection, this is only for transportation. That's why I got a little...
Okay, yes.
Because you said that there's a big thing where the collection is happening, and this is more or less for transportation. So maybe I'm not understanding. This is why I asked the question, is this the unit which does the cleaning and everything and collection? Or there is another unit which does the collection and cleaning, and this is just for transportation?
Yes, the idea from this first stage, it's to collect the first part of the rain that it's polluted. But before installing the systems, it is necessary to transport many systems that are empty with air, and these solutions do not they are transporting a lot of air, empty air in the containers, and it is expensive, this method. And the idea of stacking the containers is to avoid transporting a lot of air.
Yeah, no, I understand transporting the empty ones. I'm not clear on, I understand that you're saving that part of it, but I'm just wondering how much of is that a big problem today? And, is that a big part of the problem or, not? So I don't know the answer to that.
We are installing here in Mexico around 20,000 systems every year. So we need to transport 20,000 of these blue containers, and a solution is to not do not transport empty air, empty boxes, but all stack them, and instead of transporting, I don't know, 50 rainwater collectors, we can transport maybe 200 in the same truck, and then we can install them in the houses, and it is cheaper in that part of the process.
So once they're installed, that's it. Then you take them anywhere.
No. Once it is installed, it is not removed from the house. It stays there.
Ah, okay. This is what I didn't know. Okay.
Thank you so much. Okay, Lily, any questions?
No, only have one question. This is a project that it's an idea, I guess. But did you made a cost about your project? Because you say that you have a competition very expensive. So I don't know if you made a cost about your project.
Yes, a month to produce these containers cost around $20,000, and we need to sell around 500 to have a return of investment of the month.
Okay, thank you.
It's expensive, yes.
Thank you. Okay, so we're gonna go to the next one, which is Jose Tomas from Biomoles. Are you ready, Jose? Thank you so much, Edgar. Thank you so much, judges. And this is the last project. So Biomoles, are you ready? Hopefully he fixed all his audio issues we tested. So thank you. Are you ready, Jose? Can you put your camera on, please?
Okay. So first of all, thank you for waiting for me.
Your camera is off.
Yeah, I'm gonna keep it off meanwhile.
Sí, señor Guillén, buenos días.
Sorry?
Yes, your camera is off.
Yeah, I'm gonna keep it off meanwhile I do the presentation because I think I have an internet issue, and for the questions I'm gonna turn it on. Is that a problem?
It's okay. Go for it.
Okay, great. So we are Biomold, and we build advanced manufacturing processes for a circular economy. There's a revolution within the plastic industry. Say goodbye to plastics and say hello to wood pulp. This is something we've all witnessed in our daily lives. Our bags have shifted from plastic to cardboard, and this has had an effect on the molded fiber industry with an unexpected growth as we shift from styrofoam packaging towards molded fiber protection. This industry is key for a circular economy as it builds low-cost parts based on cellulose, which is recyclable and biodegradable in its afterlife. But the molded fiber industry old workflow inhibits innovation. The manufacturing process of their molds relies on manual cutting, forming, and welding of a mesh. As a result, the molds are expensive and slow to produce. This has slowed the industry growth and the capacity to enter new markets. Current advanced manufacturing alternatives haven't been able to withstand the process pressures, so they don't really work. Plastic packaging produces 146 million tons per year, which is a huge impact in the world. This corresponds to 40% of the global plastic waste. Therefore, solving this problem is an urgency if we aim to reduce plastic waste. This industry has the potential to replace 50 to 100 million tons of plastic for biodegradable materials. That's why it's so urgent to accelerate their expansion. How do we solve all these problems? How do we accelerate the growth of this industry? We develop high-performance 3D printed molds. Our molds use state-of-the-art design and fabrication method that breaks the trade-off between the mechanical properties or the stiffness and the water drainage capabilities of the mold. How do they work? These molds are submerged in a slurry, which is a mixture of water plus fiber, and a suction process made it absorb the water and release a molded fiber part. That's why the water drainage is so important and the capacity of withstand these pressures in a lot of cycles. Our technology provides long-lasting molds at a low cost, something that none other supplier or producer has done for the market. Our value proposition, we have high mechanical performance molds that are fast to produce with a high mechanical performance. Most importantly, our method reduced the mold lead time by 90%, the mold manufacture cost by 95%, and the equipment investment by 80%. Our total addressable market is 4.4 billion for the non-commodity molded fiber manufacturers, which is a new kind of manufacturer that is growing really fast. Our business model, we have a B2B direct selling of molds for the molded fiber producers. Our molds will have a cost of $2,500, which is mostly nothing compared to the current $50,000 that a mold cost, which it corresponds more or less to 5%. Our client spent more or less $300,000 per year per client in molds, so we have a target market of $50 million per year. What do we really do? We accelerate the transition towards a circular economy by making an industry that has the potential of reducing 50 to 100 million tons of plastic waste. And our workflow will enable the local production of molds, enhancing local resilience, which is something really important as we have been facing this pandemic. Our team is me, Jose Tomas Dominguez, a mechanical engineer, and Paloma Gonzalez, a researcher who's been working with me in researching the replacement of plastic with molded fiber alternatives. Thank you, and I'm waiting for your questions.
Okay, thank you, Jose. So I think, first of all, very clear problem definition. And, I think I understand what you're trying to do. By the way, I think there's a huge market for it. So I agree with you on that. What I'm not clear on is, I didn't understand so you are making the molds for the products which will be molded. So these molds, if you can tell me, I understand the process for the plastic molds which are created, but you are doing it for these biofibers. So maybe if you can just repeat what the current process is and how is your process different from what the current if you can, because you talked about 3D printing, but then I'm not sure if the 3D print, how those molds work. So can you please explain that a little bit again?
Perfect. I expected that question, but I couldn't take more time on explaining the whole process. But yeah, so how do this mold works? This mold, as you can see here, are submerged in a slurry.
Are you showing something? Sorry, I apologize. I'm not seeing anything.
Yeah, I stopped screen sharing. Sorry. There we go. So, as you can see here, these molds are composed of these molds, what they do is that they are submerged in a water plus fiber slurry. The water is absorbed and a mesh will retain the fibers, getting as a result the molded fiber part. So how are these molds built? Give me a second. You can see it here. So in the image at the right, you can see in the corner, there's a base part which has lots of holes and it's covered by a stainless steel mesh. So that mesh acts as filter and retain the fibers when you absorb the water. The problem with this process is that specific mesh has to be handmade. So as you can see in the image at the right, they're using, in this case, a hammer. Sometimes they use pressure machinery, but the 3 stages are mostly made by hand, which is forming, cutting, and welding the mesh into the current mold standard. I don't know if that answers your question.
No, it answers my question. Now, my follow-up question, I think you have to tell me now what the second part is. So I understand that instead of creating the hand molds, you can 3D print these molds.
Exactly.
Okay, I get it. But what is your innovation in there? So you can take a 3D printer and then create those 3D molds. So I'm trying to understand, what are you guys doing? What is your innovation? So I get it that you can now 3D print a mold instead of making it by hand. What is it that you are doing? What is your innovation in there, right?
Perfect. So the problem in here at first is that machinery use the feasibility to make a mesh that it's really thin in their porosity. It's a hard process. The logic step that everybody will take is to make like a thin layer that covers the mold and cover it through holes. And that's the approach that the market has been doing. But that there's a trade-off in there between the whole diameter and the mechanical performance of that thin layer that will cover the mold. That will be our mesh. So meshes didn't withstand the process pressure and they break easily. Therefore, they didn't really work for more than 100 cycles or things like that. Our innovation is, there are 2 main innovations in here. One is the architecture of the mold. We completely redefine how the mold is built, and our architecture takes full advantage of 3D printed technologies, enhancing the mechanical performance. And the other innovation is how we build the mesh. Our meshes are built through a design process that breaks the trade-off between the mechanical performance and the water drainage. So it really can drain water at high performance without losing their stiffness and therefore withstanding a bigger amount.
And this is the mesh so let's say you 3D print the mold and the mesh just gets applied to it. How do you assemble the mesh in the product?
That's the innovation through the architecture. The mesh is incorporated in the product itself. So it's just one component.
So you're 3D printing, you're 3D printing the mesh as well?
Yes.
On the product. So, and you talked about these different properties. So what 3D printer, what type of a 3D printer are you will you use or are you using for that?
Currently, we're using SLA technologies. The design process and the architecture is agnostic to the 3D printing technology. It doesn't work with FDM because they don't have the resolution currently to make this kind of printers, but it could work with SLS, FDM, MDF, I don't know, different high accuracy 3D printing technologies.
And have you tried anything yet? Like you have printed and tried these things? Have you created anything, any mold? I mean, any products?
Yes, this one is our mold that uses, this is a mold that uses our technology. This is a prototyping machine, not a industrial, like high level production machine. But we know it withstand the process pressure and they use it for 100 cycles with no problem regarding the mold. So
this is it's very fascinating for me. Now, my last question, because I'm not familiar with this, it seems very innovative. Are you unique or somebody else is already doing this? 3D printed molds for biodegradables?
There's 3 companies making this mold. Stratasys tried like 5 years ago, and I know their technology didn't work. It didn't withstand more than 10 cycles, so they dropped off. They still have the software, but nobody's using it in the industry. HP is entering this market, but their architecture and the way they build the mesh has made their molds also with a smaller lifespan than our molds. And there's another company with that it's using metal 3D printing to print the molds. So their molds are even more expensive than current industry standards, presenting the exact same problem previous molds had, that they are really expensive. So nobody wants to enter this industry. There's a huge entry barrier that it's like, okay, I want to test my product, and you have to invest like $100,000 per test. So the workflow of this industry doesn't really enter into the like fast prototyping workflow most industries uses. So yeah, that also has slowed the acceleration of the industry.
Okay, thank you. I think I'm clear. So your innovation really is something what other 3D printing companies, large 3D printing companies like Stratus and HP have tried. You have some innovation to make sure based on the way you characterize the material properties or whatever, I'm not sure, but somehow you are able to make it better and workable.
Yeah, that's a good resume.
Okay.
Hi, Jose. I'm Lily. Thank you for your presentation. It was so innovator. So in your business model, you are selling the models, or is more consultancy for modeling?
No, what we've done, what we're thinking of doing is the molded fiber producer. I'm sorry, my baby was distracting me. Okay, a molded fiber producer has this client. Normally the clients come into them with what I call like the molded fiber desired product, that it's the output of the process. So the molders are gonna send us the product. We're gonna design the mold, fabricate the mold, and send it to them. Just the mold, in case they already signed it, will have a cost of $2,500. And a production cost that is like $250.
Okay, thank you very much.
Just a comment, Jose, you may want to consider, what I've seen in the industry, in 3D printing, one is to actually provide the mold makers and so on, but you may want to have a relationship similar to companies like Carbon 3D and others which are doing, where, for example, Carbon 3D has a direct relationship with Adidas to produce a customized shoe. You may want to actually I think there's probably less money for you to provide the molds, but maybe you actually want to have a service business where you actually provide in the end direct goods for these big companies using your processes, whatever, and your business model. So my advice would be is think in that direction as well, because then you're providing end goods and you're optimizing all the 3D printing and processes. I do understand that requires infrastructure and everything, but that might be part of the business deals you might do with the end customers, if you will. Yeah. Anyway, something to think about for you.
Great. Yeah, we had an opportunity of something like that with Formlabs, which are willing to change their packaging from styrofoam towards molded fiber. So that's also an approach we've been thinking about. Well, business models constantly change for startups, so that's something we're analyzing, to be honest.
Thank you so much, Jose. All right. So now, just going to briefly, thank you so much for the judges. Thank you so much. Thank you, Lily. Thank you, Sushit, and thank you, Armando. So now, just in a very briefly, I'm going to show you and present to you a small video about the 3D experience world, and also explain you all the points and how does it work, the evaluation of today. So just for you for all to know, you crossed the first track, which is called business development, which accounts for 25 points, and then you solve 2 missions there, which is the value proposition and the business model. From there, you also went into the product development track, where you solve 3 missions from the loot boxes: the 3D experience 3D model, then your build of materials to check the feasibility of production and manufacturing of your products, and then from there, the 3D experience to refine your model. This accounts for 50 points. From there, the smart funding loot box from the track number 4, which is called, which is actually your pitch deck. So in your pitch deck, you actually are building these 12 points for your main presentation, and this will account for 25 points. And as for today, the 3 judges are evaluating each of the teams and are giving special value of the innovation, the product usability, and as well for for the business feasibility as well. So they're going to, with these points, you're going to get these next 25 points. And this is how we're going to evaluate to get your prize, like to get the 3 final projects that will actually get, well, they will divide this budget for manufacturing their project and their product and then ship it to Atlanta to the 3D Experience World Exhibition. As well, we're going to help, we're going to support one member of each team to be there representing their project and also exhibiting it at the 3D Experience World in Atlanta. And this is how we are going to evaluate, and this is how you're going to get the prizes. And for now, I'm going to just present a brief video about from the 3D Experience World. You can hear the sound? Okay, 1 second. There you go, perfect. Thank you. And now I love to give the microphone to Sushit. Welcome, Sushit. Maybe if you can, yeah, just give some words to the entrepreneurs that, from the 3D Experience, from the Makers for Good make-a-thon at 3D Experience World 2022.
Well, sure. Thank you, Oscar. Of course, I commented quite a bit on the presentation. First of all, congratulations. And I would say, you know, a job very well done by everybody who was presenting. It's always, I mean, I participate and I love these presentations because there's a lot of innovation shown and excitement shown. And especially when it comes from, you know, different parts of the world, it's to me is just amazing, because as we go around the world, you know, the means and access to production and technology is different. But what is the same across the world is the passion and the innovation which presenters show. I find it always consistent. And in fact, believe it or not, earlier in the morning, I was in a presentation from India, all the way India. They have a competition they do across India with close to 4,000 students participating, and we had the final results, a similar type of a thing, but different. So innovation is happening everywhere, and we, of course, at 3D Experience Works, Dassault Systems, SolidWorks, we're just proud to be part of it. And you know, of course, there are over 6 million users of our products being used and doing the kinds of innovation you do. I want to make a couple of points which might be helpful for you. And some of you are great entrepreneurs and you already know it, but for others, it might be relevant. One is I want to just differentiate between innovation and invention, because I know that a lot of times we glorify invention. All of us want to create the next biggest thing, something which has never been done before, and or invent. And I would say the difference between invention and innovation really is that innovation is just about solving existing problems, and you don't have to invent something totally new. It's a matter of using what we have and putting it in a different architecture. In fact, the last presentation was a good example of what I would call is innovation versus inventing something new. And it's in the end, that's there. And then the other part of innovation, so once we say, well, let's innovate, it's not just about an idea as well. And what I saw in the presentations today is what's not just, hey, here's my idea, and I'm done with the innovation, right? So it's not just ideation, but it's also execution. Because to tell you frankly, everybody has an idea. I can tell you, if you go around and talk to various people, everybody has an idea. But an entrepreneur is when they take the idea and actually execute on it, because that's the 99% of the work, if you will, idea. So don't stop at the idea. Execution of it is the biggest thing. And I think if you do that, then that'll be awesome. And I do believe that you guys are all sort of creating the world we see around us, right? And you're part of it. So we have to solve those big problems, if you will. And maybe I'll close with, and actually I have an ask, and maybe Oscar, you'll have to help me get that ask for 3D experience work. So there's an interesting article I was reading in Popular Mechanics, and they were talking about, we have all these innovations happening. What the world of machines, what are the innovative machines which will be there in the 2100, the future machines of the year 2100. And what they did was they posed this question, because right? I mean, in 1900s to now, things have changed quite a bit, and so many inventions have happened. And they were talking about far in the future, if you look at it, and they asked a lot of the scientists and the innovators, some famous ones, what would be the future machines of the year 2100? And, of course, they got replies from space elevators, which actually is a customer of SolidWorks trying to do something in there to create elevators to space, to tiny machines, swarms of small robots. People talked about flying cars, autonomous cars, which are happening now. They talked about the new ways of human and machine, interaction. So here's my challenge, and Oscar, you're going to help me. If I were to pose this question to all you guys, the ones who presented today, and I said, well, how do you see what will be the future machines of the year 2100? If you can give me your answer on that, a 10-second video or less, or what 2-line on it, what you think would be the the future machine of the future. A, I would love to hear your answers. And B, I would like to showcase that collage of that videos of all you guys at 3D Experience World in January. Okay, so that's my ask. But with that, I'll just close by saying that here we at SolidWorks and Dassault Systems, we are here to support you, and we're going to produce all the tools so you can make the innovations, to create the future with your help. And don't stop at the idea. Idea is nothing unless you execute it, which you guys are already trying to do. And we'll help make it happen. So that's that. And thank you.
Thank you, Sujit. Yes, of course, we're going to help you that. We're going to make that collage so we can showcase. So guys, you have some work. Start thinking of the machines for 2100. That will be really cool. I think that's going to be an amazing inspiration. We really love to see that. and play it there at the 3Experience World 2022. Yeah, definitely we're gonna do it, Sushit. Yeah, we're gonna work on it. Thank you so much, Sushit, for your support and your words and your wisdom. And right now, well, for everyone to know, we're going to go into the back room, evaluating all the projects and summarizing all that happened. And we thank you all for all your work and your hard efforts throughout these 20 days. We believe that your projects are going to create a lot of impact and are going to change things in the industries you're participating in. Hopefully, we wish you the best. And as well, if you don't win, you can still go to the 3Experience World 2022 because, as we mentioned before, you have conference passes that the Solar System SolidWorks is supporting you. So hopefully, if you're not one of the three finalists that create prototypes, we can still we still wait for you for creating community there in Atlanta. And of course, Sushit will meet you there, and Abhishek, and all the community of the Solar System SolidWorks. And we really love to see you there. And we really thank you for your effort. Keep it on, and all the best for 2022. We thank you, and we will let you know at 3 p.m. Mexico City time the results for the 3 winners that are going to manufacture and go to the 3Experience World 2022. And now we're going to close the session, and we're going to just go to another room with Sushit. Sid, can you take us to the other room? And with Lydia as well. Thank you, everyone. Thank you so much. Thank you all the support from Makers for Good team. Thank you for all the mentors that as well make this happen as well, supporting all the projects. And thank you, the Solar System SolidWorks, all the support and the amazing tools that you make to make this happen. Thank you so much always. And thank you so much, Sushit, for being amazing always behind all these makers around the world. And of course, all these being behind the Makers for Good platform. Thank you so much. Thank you so much.
Thank you.
Thank you very much.
Thank you. So we're going to go to the other room.